the expression is a polynomial or not, and tell its degree. You understood the meaning of degree, right?
Yeah.
What is degree? Degree of a polynomial?
The highest power.
Highest power. And the powers will always be?
The powers will always be in positive.
Yeah, all positive integers, or you can say whole numbers, right? Very good. Very good, very good, very good. Coefficients we understood. We understood degree. We did this in practice. Now, you know, Ankita, you understood the meaning of terms, right?
Yeah.
Terms and degrees. So based on terms and degrees, we have classification of polynomials. Based on terms, we have different names for polynomials, and based on degree, we have different names of the polynomials. So when you say mono, what do you understand by that? Mono.
Mono means one.
One. So example, monomial means, having one term. For instance, minus 2x squared or minus 5 by 7x. Or you may have two variables also. We will not be dealing in two variables in our chapter, but for an example, you may have like minus 3xy. This is also a monomial. There are no two terms in this. There's just one term. Binomial. Bi means?
Pi?
Binomial.
Bi means,
yeah, what?
so two terms.
Yes. So for instance, x plus 2 or 7 minus 5y, right? 3 minus 2x squared y. All of these are binomials. Here we have two variables. In others, we have one variable only. Trinomial means?
Trinomial means three terms.
Very good, very good, very good. For example, x squared minus 2x plus 3. Or it may be xy plus x plus y. That's trinomial. These are trinomials. Then we have polynomials having 4 terms, polynomial having 5 terms. All those will be known as polynomials only. Okay, you won't give specific names. Monomial for 1 term polynomial, and binomial for 2 term polynomial, and trinomial for 3 terms polynomial. All of them are polynomials only, but beyond this, you will just call it a polynomial. Polynomial with 4 terms, polynomial with 5 terms, 6 terms, and so on. That's the classification based on terms. Now let's think about classification based on degree. Now I told you, Ankita, degree means, first thing, polynomials will always have whole numbers as power. And whole numbers begin in 0. So you may have degree 0, degree 1, degree 2, degree 3, degree 4, and so on. Are you getting me?
Yeah.
So these are degrees, okay? Degree 0, degree 1, degree 2, degree 3, and degree 4. Now, what is degree 0 polynomial known as? Degree 0 polynomial is known as
constant.
Very good, because there is no x visible in it. There is no x visible in it. For example, px is equal to simply minus 5. Or px is equal to simply minus 7 by 11. All of these are constants because you have minus 5x power 0. There is no x visible in it. Hence, it is a constant polynomial. Got the picture, Ankita?
Yeah.
Great. Linear would mean degree 0. Can you give an example for linear polynomial?
Linear
Take one.
polynomial,
Yeah.
5 raised to 1.
5 raised to?
5x raised to 1.
Yes, just 5x. Or it can be like this. Px is equal to 6 minus 2x. Or it can be like this. Px is equal to 3 by 2 minus 7 by root 2 y. Even though root is there, root is on a constant. Do you see that, Ankita?
Yeah.
So y is free of root. Y has power 1. It is a linear polynomial. Okay, degree 2 polynomials would be known as quadratic polynomials. Let's create an example, Ankita. Quadratic polynomial.
Quadratic polynomial, 10x raised to 2.
Yes, simplest of examples will be x square. You may have x square minus 4, or you may have 3 terms also, trinomial also, like this, x square minus 2x plus 1. All of these are degree 2 polynomials. Highest power is 2, so they are quadratic. Similarly, we will have cubic polynomials like px is equal to x cubed. Simplest one will be this. Then it may get a little larger, like x cubed minus 8. It may get as big as this. Px is equal to root 2x cubed minus root 5x square plus root 3x minus root 7. See, all of the coefficients have roots, but the power on the variable is whole number only, right? So this is a cubic, because it has the highest power 3. And the last one is biquadratic. Biquadratic means degree 4. So the simplest one will be like this. Px is equal to simply x power 4. That's a biquadratic polynomial. And it can get bigger, like x power 4 minus 3x squared plus 2x minus 1. See? Got it, Ankita? Is it understood up to here?
Yeah.
Very good. So that is classification. You got the videos? Recordings of the previous classes?
I'm not sure, sir. I think I would have got
I
my mom
shared it.
said-
Yeah, I shared it with your mom. Okay. So you
Oh,
can copy the link and save it somewhere, right?
yeah.
Or bookmark it in Chrome so that you can go to that Google Drive folder and see your recordings. Okay, let's classify. What is the first one like? Constant, linear, quadratic, cubic.
So I can't hear you.
You don't see the question.
Okay, classify. First one, x minus x cube, it's cubic.
Cubic. First one is cubic. Quartic and biquadratic is same thing. Okay, quartic or biquadratic is same.
Okay.
So first one is cubic. That's fine. Second one,
Quartic.
quartic or biquadratic. Quartic. Okay, next.
Linear. No, quadratic, sorry. Quadratic.
Quadratic. Okay, next.
Raised to 0. Constant.
Number 4 is constant. What do you see in
So
number 4?
I'm confused between constant and linear. So constant, it has to be raised to 0.
Yes.
Then only we can say, okay. So that means it's linear.
Linear. It has highest power 1. So it is linear. Okay, next.
Next is cubic.
Cubic. Okay.
Next is linear.
Huh?
Linear.
6. What is it in 6?
3.
So 3. Do you see x there?
3 will be a constant.
Yes, it is a constant. Okay, what is the next one?
T square is linear.
Yeah.
Quadratic, sorry.
Quadratic. Okay, next.
2 plus x. So what will you say for 2 plus x?
You think I've just explained it. I need an answer from you.
2 plus
What is the
x.
highest power? If you make it standard, try to make it standard.
2 plus x.
Do it on paper. Try to make it standard. Standard means highest power to lowest power, and you know it must have the missing terms also, if there are any.
I don't think there are any missing terms.
Okay, so what is the highest power? Highest power on the variable. Highest power on the
Is
variable.
highest power on the variable is 1.
1. So if the highest power is 1, degree is 1, what is it known as? What kind of polynomial?
Linear.
Linear. So that's what I was waiting for here. Next one.
Here it's 5x.
5t.
5t. T is acting as the x over here.
Yeah.
It's linear.
Linear. Very good. Any confusions? Please tell me, please. Which
No,
one is
sir.
confusing for you? I mean, you are confused between constant and linear.
Yeah, a little getting confused over there only.
Constant means the highest power should be 0. So this is actually 3x power 0 now. So it is a constant one. There is no x in this. Power is 0 for x. But this one, for instance, it is 5t power 1 minus root 7t power 0. So there is a power 0 here. There is a power 1 here. Highest power is 1. So this is linear. Got me?
Yeah.
This one, for instance, you are very confused in this one. So if you arrange it, first one will be x power 1. Then we have 2x power 0. So there is a power 0 here in the first one, in the last one, and power 1 here in the first one. Maximum power is 1, so it is a linear polynomial. Kidding me?
Yeah.
Very good. Now we are going to go into something different. Value of a polynomial. Polynomials are like machines. Okay, Ankita, telling you actually, right? Polynomials are like a machine. You input something like washing machine. In washing machine, what do? You input your dirty clothes and water and detergent, and what you get from the washing machine is clean clothes, semi-dry clean clothes, right?
Yeah.
So polynomial work in the same manner. They are machines. For instance, let's say we have a polynomial like this: x cubed minus 3x plus 5. This is the machine. You will input something and the input will go here. Okay, just like in washing machine, you put your clothes in the cavity that is there where clothes are to be put, bucket, right? And you input your detergent at its own place, water at its own place, and ultimately you take out the clean clothes. So input will fit in here. Input will fit in here. That means access value will be the input. So for instance, we are writing like this: f5. we are inputting 5 into the machine, and 5 will fit in here. X is present here, X is present here, 5. Come on, read it once. 5.
5 plus, no,
5 cubed. There is a cube here,
no,
right?
5 cube. Yeah,
5
5
cube.
cube minus 3 into 5 plus 5.
Okay, so what is the machine gonna give you? 5 cube is
125
125 minus 5
minus 15.
is and plus. So this is 115, right?
105, right?
105. Nope, it has to be 115, right?
125 minus 15 itself is bringing 110.
110 plus 5.
Oh, okay. Yeah, 115.
Got it?
Mm.
Great, wonderful, wonderful. So did you see how it works like a machine? This is the output, okay?
Mm.
This is the output. The input was 5. The output is 150. Let's do a few questions based on this, Ankita. Come on, solve and get me the answer. Come on, do it on paper. Px is equal to 3x squared minus 5x plus 6. You have to find out P2.
4, 12 minus 10 plus 6. 1 minus 10, 2 plus 6. First one is 8.
8. I'll note it. 8. Okay. Output is 8. Okay. Next one.
Next one. 4 into 2, 8 minus 2 root 2 into 2 root 2 minus 1 plus 1. Second one is 1.
Second one is 1.
Yeah.
Seems so. Very good. And
Minus 1. Minus 1. 4 plus 2. Minus 6.
minus 6. Absolutely. Fantastic. Fantastic. So you did it all. I don't have to do it. Right? Did you write in a proper format? Like I'll just show you one of them. For instance, number 2. I'm doing number 2. So you got to write like this: Q input 2 root 2 access value, that is access value, 2 root 2 squared minus 2 root 2 times. Did you write this way?
So I just did the rough calculation.
No, on paper you will have to write, because you will get marks based on what you write on paper, right?
Yeah, sir. I'll write in the paper.
Yeah.
I can write like this. Yeah.
Very good, very good. So this is 8 minus 8 plus 1, which is 1. Fantastic, fantastic. So you're done with this. Now, something interesting is going to come up. Here you got 8 as the answer output. Here you got 1 as the output. Here you got minus 6 as the output. But when the output is 0, it is something significant, something very important when the output is 0. For instance, let's go into this. Try to find out these things. X cube, P0, P1, and P2 in this one.
So I can't hear you.
Am I audible, Ankita?
Yes, sir. Now you're audible.
All right, so find out P0, P1, and P2 in this one, please.
Oh. 0 first. P of 0 is 0.
What about P of 1?
What's up?
Next one, P1.
Okay. P of 1. Also 0.
Okay, P2.
Zero.
Very good. So you see that P0 is 0, P1 is 0, P2 is 0. In all of these, what were the inputs?
Inputs were 0, 1, and 2.
Very good. This x is equal to 0, input x is equal to 1, input x is equal to 2. These are going to be called by a name. These will be called by a name called zeros. These are called zeros of the polynomial. Heard of this?
Zeros of the polynomial. Yeah.
Zeros of the polynomial px. Are you getting the picture?
Yeah.
Try to find out P3. Try to find out P3 in this case. See what you get.
3. Okay. You'll get 6.
6. Positive 6, right?
Yeah, positive 6.
Okay. So are you getting the polynomial output as 0 here? No. In this one, are you getting the output 0?
No.
No. So this input x is equal to 3 is not a 0. Not a 0. Are you getting the point?
Yeah.
You will have the inputs called zeros only when the output is 0. The input will be known as 0 only when the output is 0. Otherwise not, right? Is it confusing, Ankita?
No.
No, very good, very good. So you understood it. Let me clear this and tell you, the definition. We would have it like this. X is equal to alpha. Let's say this is some number. Is a 0 of a polynomial px if and only if p alpha, when you input this, the output should be 0. Are you getting me? This is the definition. All right, Ankita.
Yeah.
So you understood the meaning of 0. Now, what is the procedure of getting 0? For instance, suppose it was not given. This was not given. How would you figure out the 0? For instance, let me take another example. Let's say we have px is equal to 2x minus 4. What do you think will be the 0 of this?
0 of 2x minus 4. 4 by 2. 2?
Yes, that's trial and error. you are doing trial and error to find out what will be the zero, right? X is equal to 2 definitely will be the zero of this polynomial. But if you couldn't do the trial and error thing, you are placing one value at a time and checking whether you are getting zero or not. If you couldn't do that, how are you going to solve this? How are you going to find out the zero? Look, we know that
You equated?
Yes, Ankita.
You equated to 0?
Yes, absolutely. That's what I'm trying to tell you. Since you know that you are finding out zeros, you have the polynomial equal to 0, right? Polynomial should be equal to 0, right? The output should be equal to 0. So we'll write like this: for any zeros, our polynomial should have the output 0. Polynomial's output should be 0. So what is the polynomial in our case? In our example, it is 2x minus 4 equal to 0. So what is 2x going to be? It's 4. What is x going to be? It's going to be 4 by 2. It is 2. That's what you did here, right?
Yeah.
Fantastic, girl. Ankita, wonderful, wonderful. So you are aware of zeros. Very important, okay? When we go into factor theorem and factorization of polynomials, we would need the concept of zeros. Okay, let's do a few questions on this. Get it done. Come on. What are the zeros of these two polynomials? Use the method I just explained to find out the zeros. Yeah.
Minus 5 by 5 by 4.
Yes, the first one is correct. Next one.
2 by 6.
2 by 6 can be simplified a little, I guess.
2 by 6 can be simplified 1 by 3.
1 by 3. Fantastic, fantastic. Okay, Ankita, let's rejoin the class because it's gonna end.